In this session, I'm going to prove the power rule of differentiation. The power rule states that the derivative with respect to x of x to the n equals n times x to the n minus 1. Now, to accomplish this proof, we're going to use the limit definition of derivative again. And so we have the limit as delta x approaches 0 of x plus delta x to the n minus x to the n over delta x. Now to continue, we're going to have to do a binomial expansion of this. So we have the limit as delta x approaches 0 of x to the n plus n x to the n minus 1 delta x plus n times n minus 1 over 2 x to the n minus 2, that got messed up, n minus 2 delta x squared plus however many other terms there are plus n x delta x to the n minus 1 plus delta x to the n minus this last x to the n, x to the n. And we're going to put that all over. Let's draw a line underneath here. Let's change it to solid. Okay. Over delta x. At this point, we should notice a few things in here. The first is that we have an x to the n here and a negative x to the n. So those two are going to cancel out. And now notice every other term that's left in this numerator has a delta x in it. We also have a delta x in the denominator. So what we can do is we can factor out this delta x, we can divide out this delta x, and one of the delta x's in each one of these following terms. So what that's going to net us is the limit of delta x approaches 0 of delta x factored out with n x to the n minus 1 plus a bunch of terms plus delta x to the n minus 1 all over delta x. And now we can get rid of these delta x's, and we have the limit as delta x approaches 0 of n x to the n minus 1 plus terms plus delta x to the n minus 1. Now we can see that as we take the limit as delta x approaches 0, all these intermediate terms are going to go to 0. Everything in here is going to go to 0, including this one, and what we're left with at the end is n times x to the n minus 1. And there you have it. The derivative with respect to x of x to the n equals nx to the n minus 1.